Lesson 1.5 is cumulative distributions. And cumulative really just means total. A function whose values are cumulative frequencies or cumulative relative frequencies is called a cumulative distribution. So we have a table with monthly precipitation in LA in inches and cumulative precipitation. So the first thing we'll do is find the missing values in the table. So how this table works is essentially for 2.4, it's just 2.4. And then we add 2.51 and we get to 4.91 cumulative. Add 1.98 and get to 6.89. Add and get to this. Add and get to this. And so we add 7.75 plus 0.03, and we get 7.78. So that's our missing value right there. And then we keep going, add and get this one, add and then get this one, add to 0.31, get 8.25, add and get to this. Then we have another question mark, so we know 8.59 plus that question mark gets us to 10.35. So if we subtract 8.59 on both sides, our question mark or missing value is 1.76. So in November, there were 1.76 inches. And now we can draw a bar graph of cumulative precipitation by month. So our x-axis, we'll do all the months. So January through December. So let's say January's right there, February, March. Do your best to make them even, but it won't be perfect. April, May, June, July, August, September, October, and if you're like me, you're going to have to add another one and another one. And we'll draw a cross. This is kind of ugly, but it can be. It's no problem. Okay, and then that's November and December. The y-axis will be our cumulative precipitation in inches. So that's what our data is given to us as in the table. And so now it looks like the highest cumulative precipitation we have, I'll switch colors to be maybe a little clearer because I like to switch colors. The highest we have is 12.01. So let's just go up by 1. So 1 inch, 2 inch, 3 inches, 4 inches, 5, 6, 7, 8, 9, 10, 11, 12. So that works out fine because our highest will be right above there. So then in January, and again, we're looking at this column right here. In January, we were at 2.4, and this is really going to be an estimate. 2.4. February, 4.91. So just under 5. Whoa, this is a very ugly graph. I'm sorry, you guys. I apologize, but maybe it'll make you feel extra good about yours, right? March, 6.89. So just under 7. If you want to pause the video and do it yourself and fast forward, that's fine. April, 7.61. So right between 7 and 8. May, 7.75. So not much rain happened in May, it looks like. Didn't go up by much. June was 7.78. Again, it's kind of hard to tell on our graph that these are even different. That's okay. Let's just give us the general idea. July, again, for our purposes, pretty darn close. Our graph's not big enough to be able to tell the difference among 7.61, 7.7, 7.78, 7.79, and even August is really about the same again, 7.94. And we finally go above 8 in September. Um, 8.25 and then 8.59 in October, 10.35 in November, got some more precipitation, and then our 12.01 in December. Okay, so the idea is you kind of look and you can follow along and say, okay, well, we started here. It looks like, you know, there was a lot of precipitation here, and then it kind of flatlined and nothing really happened, and then gradually it started to rain or snow more. Okay, that's kind of what that shows us. So now we're looking at when is 3/4 of the precipitation fallen. Well, 3/4 is 75%. So 0.75 times the total, which was 12.01. So this is 3/4. This is the total. And that equals 9. And so looking at our data, the end, because again, these are all at the end of the month. The end of October, there was 8.59 inches. And the end of November was 10.35 inches. So 3/4 fell somewhere in there between the end of October and the end of November. So 3/4 must have fallen during November. Okay. Switching gears a little bit, let's talk about percentiles. So the nth percentile means that this is the value in a set such that n% of the values are less than or equal to that value. The definition is kind of iffy, but examples will hopefully help. So here, for example, if your score is in the 83rd percentile, 83% of people had the same score or lower than you. So we have 35 scores for a biology test. And we have some data to work with here, or some scores rather. So what I want to tell you is the formula we'll use with percentiles. And the formula is position equals percentile times n. This is what we will use for all of them. N equals the number of values, and you need to write percentile as a decimal. Okay. So if we're finding the percentile rank of 89, and we have these 35 scores. So we know that position, I'm going to make it POS, equals percentile PER times n. And our position, these are in order, so it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's where 89 is. So our position is 27 equals, our percentile is what we're finding, times our n, which is how many scores? 35. So to solve for our percentile, we can divide both sides by 35. So our percentile equals 27 over 35, which is 0.77. And so this is the 77th percentile. And what this means is that 77% of people scored less than or equal to 89. Sometimes we'll solve kind of the other way. What test score is in the 20th percentile? We set it up the same. We still start with position equals percentile times n. So now the position is what we're looking for. So position equals, percentile is 20th, so we have to put that as a decimal. So this is 20% is 0.20, and our n is 35 scores. And 0.20 times 35 is 7, so we're looking for the value in the 7th position. So the value isn't 7. But if we go up and find 7th position, 1, 2, 3, 4, 5, 6, 7, it's 70. So the test score in the 20th percentile is 70. And what that means is that 20% of people scored less than or equal to 70. Now we have the quiz scores for an art history class. First, we want to look at how many students took the quiz. So frequency 3 with a score of 6, 1 with a score of 7, etc. So 3 plus 1 is 4, plus 2 is 6, plus 4 is 10, plus 2 is 12. So 12 students total took the quiz. Now we want to look at what score is at the 25th percentile. So we'll use our formula. Position equals percentile times n. But in order to do this effectively, let's write out all the scores. So the score of 6, there were 3 of those. There was 1 7, 2 8s, 4 9s, 2 10s. And now we could use this. So position equals percentile times n. So we're looking for the position so we can find what score. Percentile is 25th, so 0.25. And our n was 12. 0.25 times 12 is 3. So it's the third position. If we go back up here, in the third position, 1, 2, 3, the third position is 6. Now let's find the percentile rank of a score of 7. Same formula. Position equals percentile times n. Position, we have to find that. It's not score, it's position. So let's look for 7. 1, 2, 3, fourth position. So 4 equals percentile, that's what we're finding, times 12. Divide both sides by 12. So our percentile is going to be 4 over 12, or 0.33, or a third. So multiply by 100, change it into a percent, the decimal place over 2. So we have about the 33rd percentile, which again means that 33% of people scored at 7 or below.